If you are developing in an object-oriented platform such as Java or .NET, you are probably familiar with interfaces. If not, then there are probably some concepts similar to interfaces in your preferred language, such as abstract classes in Python. So anyway, let's bring us all up to speed with interfaces. Basically, an interface is a contract that declares the signatures of an implementation. The interface states that given a piece of code that should do a specific task, its methods will look in a specific way. For instance, let's think about a code that performs some basic math calculations. For the sake of simplicity, let's assume it will only deal with the very basic 4 math operations. What would we expect the code method signature to look like? Probably something like that. Note that I'm using .NET to demonstrate the code, but it will look similar in other languages. As you can see, the interface defines the methods and their signature, but does not include any definition. Now, what's the point of interfaces and why are they so important? The answer is simple. Using interface allows us to make our code loosely coupled, meaning we do not tie one class to other. Let's use an example to make it clear. Continuing with our calculator example, let's assume we have a class named calculator and a main class referencing and using it. Without using interfaces, our code will look like this. As you can see, the main class must be familiar with the calculator class. It appears in its code. What will happen if you would like to replace the calculator class with a different, better class, for example, with an advanced calculator? We will have to change the code in the main class and recompile it. And that means that the classes are tied and strongly coupled. There is a saying in the software architecture field that goes like this: new is glue. What it means is that whenever you see a new keyword, as in our code here, you know there is a close tie, a strong coupling between those two classes. And this is something you want to avoid. Strong coupling classes is generally a bad idea and will make your code less modular and much less flexible. Let's see what will happen if we will use interface in our code. In this case, the main class does not new the calculator class, but rather work with an interface. The interface defines what the calculator can do, but gives no hint on what the concrete implementation of the calculator is. The calculator can be implemented by the calculator class we saw earlier, or by a completely different class. The main class will have no idea about it whatsoever. And that allows us to make our code really modular. We can switch implementation without other code blocks being aware of it. And that's the real strength of interfaces. Now, where does the implementation come from? After all, there is some implementation here. The code runs and produces results. Well, as you can see, the implementation is returned from the getInstance method. This method uses a pattern called dependency injection to inject an instance, a concrete implementation, to an interface, and this is the topic of the next lecture. And until then, remember, new is glue. Always prefer using interfaces instead of direct reference between classes. It will make your code much more modular and easy to modify and maintain.